I'm gonna go class real quick. Oh, hi everyone. Just had something come up quick. I kind of forgot. We're gonna be starting like ASAP. Let me just pull up the slides. So today we'll be going over Solidity. And yeah. Yeah, so today we're going to be doing a deep dive into Solidity syntax. So here's the overview of today's lecture. This lecture should be pretty short, so we're actually going to have time for you to work on homework, and you could ask me any questions you have about the homework. So let's go over an overview. This should be review from last week. Yeah. So then let's talk about what the bank needs to do. So then let's say we have a bank and we are encoding it with Solidity. So then a bank, any bank, would need to allow deposits, allow withdrawals, and balance checks. And here is it coded up in the slides given. Yeah, so let's talk about the contract first, and let's go bit by bit. So then the contract is very similar to classes in other languages. If you've taken 61A or 61B, you declare your state variables outside the function. The mapping is very similar to a hash table in that you could quickly get an attribute by a key. Public means that a contract is externally readable by users, but then they can't modify it. If it's private, it means that an external person who calls a contract will not be able to view what's in the balance. So then let's talk about an event. So an event is something unique to Solidity, which publishes an action to external listeners. So you call an event if you want people outside the contract to know what's going on. And then we also have something called a constructor, which could receive one or many variables. In Solidity, you could only have one constructor, so you can't have multiple class overrides. And then the message provides details about the message that's sent to the contract. So then message.sender would be the person that calls the contract. So let's say someone wants to make a deposit. So then they'd send a message to the contract, and then the sender would be this person that called the contract. So our first function will be the deposit function. In this case, we're not taking any parameters, but then we're still sending ether as we are returning a unsigned integer. Public makes it externally readable by others, so then people in the contract as well as outside could read it. The user's balance is returned as an integer. And then the balance message sender, that just increments the value because you're depositing money into your balance. And then balance is a mapping. So then sender is actually the key. And then you could fire the event so you let other people know that they have made the deposit, which is very useful because if you go to a bank, you want to know that your money goes through. Our next function will be the withdraw function. And in the withdraw function, what happens is that someone might want to go to the bank and take away money from the balance. So then in this case, we only deduct the balance before if they have enough money. Because if someone does not have enough money in the balance, we should fail the transaction because they can't take more money than they actually have. Because, so then here is the if statement that checks if your balance is greater than. If it is not greater than the amount that you want, then you don't even call it. And then also you want to send the withdrawn amount, because if you can't send it, let's say something happens along the way, the money will get lost. So then you'll have to reimburse the sender if the money can't be sent, which is what this block does.
Hey, wait, really quickly, on
Yeah.
the slide before, what is balances? Is that a dictionary or hash map? And is message like a global variable or like object?
Yes. So then message is just a object in Solidity, and balance is a mapping, which is pretty similar to a hash table. And it's public, which we have defined back here.
Okay. Okay.
Because
Can you
message
explain the
is
syntax really quickly, actually? The balances syntax.
balance.
I mean, like, just what does the syntax mean specifically? Like
Oh,
before?
so then address is a key. So then when you input a key, which is an address is an object type. It's pretty similar to an integer, but then it's only 20 bytes, which is how long an Ethereum address is. So you input an address and you get an unsigned integer or a uint. And then private modifies balances. So then you can only access balances when you're in the contract.
Okay.
Do they
So
answer?
mapping is like the keyword for making a dictionary, right? Or like a hash map.
Yeah, yeah.
Okay.
Anyone else have any questions?
Could
Okay,
you elaborate more on message? Where is it and like how is it called or
okay.
created?
Yeah, so then when you call a contract, you call it through a message. So message is kind of like a keyword. And then each message has a few attributes, including sender. I'll talk more about message later on, but then what you just have to know is that like message is a keyword. And then when you are in a contract, you're called by a message.
Okay, thank you.
Yeah. So let's talk
I
about,
have one more question really
yeah,
quickly, Nathan.
yeah, okay.
For the uint, are there different types of or different sizes of integers? Like in C, there's like uint 8, 1632, is that kind of thing? Is there that kind of thing in Solidity?
Yeah, we actually went over that a bit last lecture, but the cool thing about Solidity is that you can specify how large your integer is in terms of bytes. So you have like uint8, which is 8 bytes. You have int8, which you could use negative numbers, but still 8 bytes using 2's complements, all the way up to 256.
Okay, thank you.
Yeah, no problem. So let's talk about global variables. Yeah, but me, if you want to go over that more in depth, you should review the last lecture because we posted the recording. Yeah, so moving on to global variables. In Solidity, currency units are tracked as unsigned integers. And then the number could take a postfix of these, which are like units of ether. So you know how the dollar has like cents and dollars and dimes and stuff. So that's pretty much the equivalent of that. Yeah, so then the minimum unit is 1 Wei, and then 1 ether is 10 to the power of 18 Wei. And an ether is also bigger than another unit called a finny, which is 1,000 finnies. And then currency units without a postfix. So if you don't add anything over here, it's assumed to be Wei, which is the basic unit of ether. And then Solidity tracks times as a Unix timestamp, which is stored as an unsigned integer. To find your current timestamp, you could go on unixtimestamp.com. Yeah, here's the link. Let me post it in chat so if you guys want to view it. www. If you guys want to view it, go ahead. And similar to a currency unit, when you're actually designing a contract, there's a few ways of doing it, which is pretty complicated, but then it usually requires an oracle. But then this isn't really recommended because that just gives another vulnerability if someone wanted to attack the contract. But yeah, there's a few ways of like finding the timestamp, but then they all have the pros and cons. Similar to currency units, a number can have a postfix of seconds, minutes, hours. Yeah, we all know that. And yeah, here's a review if you want to know the units of time. And yeah, so if you guys have used Java, this refers to itself. So then this is the contract. And you do this dot balance and this dot sum function, which calls the function externally and not via internal jump. And then, yeah, so let's talk about Messenger. There has been some questions about it. So Messenger is what calls the contract, because for the contract to run, someone would need to call it. And that call is called a message. So then, for example, if there's a bank and I want to deposit money, I want to deposit 10 Wei. So I'll be the sender. And then the value would be 10 Wei. It should be in a function that's marked payable, which could receive the money. And then the data is the complete call data, which are in bytes, and it's pretty much the bytecode of the message. And then the remaining gas, because we need to remember that each transaction in Ethereum uses gas. So then we need to know that we have enough gas for the message to run, because if we don't have enough gas, then the contract would just void the transaction. And TX is a transaction. So then the origin of the transaction is the absolute address. We'll talk a bit more about this later. And the gas price is how much this current transaction costs in gas. So then
Wait, Nathan.
What's up?
Sorry, really quickly.
Yeah.
About message.
Yeah.
So how do you like load up all the values in the message, and how does it work like on a technical level? Like, do you have to like before you send it, before you send like the smart contract, you have to do like message.add sender or like add address and stuff like that, and then you send the message as an object? Like, how does it work?
There's a few ways of calling it, but then most of the time, there's like, if that's what you're asking, it's usually automated for you, and then so it's usually done automatically, but then the data is all usually in message.data as bytecode. But then if you do it via MetaMask or something, like they'll usually do it for you. Did that answer?
Okay, I see.
Yeah.
Yeah, I think so.
Yeah, so I'm just going to talk about the difference between sender and origin. It's pretty easy to confuse them, but when you write your own contracts, they're pretty distinct. So then the sender, if A sends the message to B, the sender will be A, and the origin will also be A. Pretty simple. But then when the contract B sends a message to contract C, the sender will be B, but the origin is still A. When you interact with a smart contract, yeah, you call it from, what's this? Yeah, Albert, yeah, that's a very good explanation. Yeah. Yeah, so that's pretty much the difference between sender and origin. Do you guys have any questions? Because we'll be moving on to the next slide, which is external contracts. Yeah. So then here's a simple contract. It just returns 42. And here is another contract. So then in this case, we are able to call this contract and call info in info feed from consumer. We could do that by importing the address of info feed into consumer. And then, yeah, because you need the absolute address over here. Feed.info, which is from declaring a new instance of the contract. Anyone have any questions about external contracts? Okay. Talk
Explain
about,
what you did again, actually.
what's up?
I didn't really understand what the point of what were we doing? Like just showing how to import the contract and then instantiate.
Yeah, because like sometimes you want to block your functions and classes and stuff. So that just helps you organize them better so they don't get too bloated.
But then how did you create like the info feed instance in like the set feed in the set feed of the function when you don't define like a constructor that takes in an address?
Info feed, because so then you set feed to existing contract. Wait, are you talking about this function?
Yes. Like how are you passing in like the address? It's to me it seems like you're passing into like a constructor or something for info feed, but I don't really understand what the syntax is.
Yeah, so what happens is that you're just setting you're setting feed to an existing instance. So imagine that we've already have a contract. So then what we're doing is that we're turning that contract into an info feed.
Okay. Okay. I see.
Yeah. Modifiers. So then modifiers are pretty useful because they're pretty much checks on your function. So then it makes sure that your function could run when certain conditions are met. So let's take transfer balance. What transfer balance does is that it transfers balances from one address to another. Yeah. Yeah. So then transfer balance, balance 2 plus equals from. So then you're transferring balance from into 2, and then you set balance from to 0. Yeah. Great. Yeah, so then let's talk about modifiers now. So these two are special types of functions, I guess. They're called modifiers. And what they do is they require that certain conditions be met. They're equivalent of putting these conditions right in front of the function. And for the modifier to work, you want to put an underscore in the end of the modifier on a new line, which means that the rest of the function should be after this modifier.
Can you put multiple modifiers, like assert statements kind of thing?
Yep. Yeah. As long as like the line's over here, then you could put multiple. Yeah. So then I'm going to give you guys the link to the homework. I'm going to give you like 20 minutes to work on the homework, and then we'll go over it. And then yeah, message me privately if you need any help. Yeah. So let me send the homework. It should be on the GitHub repo if you guys want to access it there, and I'll put a link on chat. Yeah, let's join back at 7.
Hey Nathan, would it be possible to post the link to the slide so we can use it as like a reference for the homework?
Yeah, for sure. Let me share it with you.
All right, yeah, thanks.
Yeah, here is the link. Yeah, that's the homework. Hi, is everyone ready for me to go over the homework? Or do you guys want a bit more time? Oh yeah, sorry, it's just dark, like the lamp broke. I was trying to turn on, but yeah, it doesn't turn on. Yeah, rip lamp. But yeah, if everyone's ready, let's go over the homework. Let me upload the answers on GitHub. And let me share my screen. Yeah, so then our first question was Tim's address is here, and he hashed, yeah, and he hashed that over here. Print player one, what would Solidity print? So let's step through the code. So what he did was he called the constructor with a value of 1 ether. And you call print player one. So let's see what happens. So when he calls constructor, player one equals message sender. And then bet amount equals message value. So let's see what happens. So then the address is this. So then message.sender is that. So then player one would be this value right here. Oh, payable in function keyword means this function could take payments. Because if a function doesn't have payable, then it can't take payments. So in take bet, what happens is that you could take payments, although this function does not do that, I don't believe. Yeah. So let's look at question 2. Mingxin's address is this, and he calls take. Oh, because like transfer is when you transfer is when you transfer it, but then payments is when you receive the money. Because in claim timeout, player transfers the money to another address, but the contract doesn't receive any of the money. So it's kind of different. But then, yeah, it is weird because.
Wait, what do you mean the contract receiving money? I don't understand the distinction between me sending you money versus the contract receiving money.
Because sometimes the contract could take money. And then, which is why you'd use payable. But then in this case, let me show you a better example. Let me find it real quick. Because this isn't a very good example.
So when you call take bet or something, you send money to the contract, and then when you call transfer, the contract sends money to the person.
Mm,
I don't know if the contract works as like a middleman in that sense. I'm not really sure, but I don't think the
Yeah,
contract has to be middleman.
I thought I did. So yeah, but that could be my bad.
Nah, bro, I have no
Decal
idea
is
what
a
I'm talking about either.
modifier in a function, and then what happens is that it allows the function to receive ether pretty much. And then, so then the function could receive ether, and then when there are, and then what happens is that like an array could, like let's say you have a mapping of deposits. Let me send it to you in the chat. So then you have something like deposit payable. So then in that case, deposits you could add message value to deposits because deposits is a mapping in the function. But then you can't do that if you don't add a payable after function.
But where does that money go though?
Oh,
Like,
the money goes, yeah, the contract is a middleman in that sense, but then you can only do payable because the contract has to reflect the money going. So it's kind of like a pointer. So it kind of points to the balance of the sender, if you will.
but if I want to transfer money to you directly, I don't have to say payable, right? I can just do player one dot transfer player two, like the code did.
Um,
I
yeah.
think this dot balance is the balance of the contract. That's what my understanding was.
Where's this stop balance?
Oh, in reveal.
In reveal.
Yeah.
So then player one dot transfer, address. Yeah, address this. Interesting, because okay. Okay, never mind. I'm wrong. So what happens is that when someone transfers money to you, payable just happens automatically. So then when you transfer money to like the contract, then payable would just execute. I got confused with payable address because payable address is when an address is, because when you have payable address, that means you could transfer money to the address.
So we don't have to put payable. Like, when do we have to put payable essentially as the keyword, and when do we not have to? When we
Yeah.
want to transfer the balance.
So then payable, you put it when you want the function to happen automatically when you transfer a balance. So then like when someone transfers funds to the contract, take bet would happen automatically, and so would the constructor. Because when someone transfers funds to the contract, if there's no constructor, then the contract won't work. So then you have to construct it automatically. Does that answer your question?
I think so. I'm still thinking it over.
Yeah, it's kind of tough and it's kind of confusing too. Yeah. If you have any questions, feel free to ask. Yeah. So were we on question 2? So let's step through take bet. So Min Qing calls take bet true with a value of 2 ether, and this is his address. So then the message, the sender of the message is Mingxing. So then what happens is that there's no player 2 right now. So player 2 defaults for 0. That's correct. But then what's the message value? Because remember that bet amount is 1 after what Tim did. So what that means is that in take bet, message.value would be 2. And this function would fail because 2 does not equal to 1. So then the player stays the same and it's still 0. So let's do this one. Question 3 is pretty similar. However, when Matt calls take bet, the value is 1 ether. When the value is 1 ether, this requirement passes and player 2 gets reassigned to Matt's address, which we see.
Wait, Nathan,
What's up?
I had a question. Does Tim have a balance of 9 at this point because they called the constructor with a value of 1 ether?
Not yet, because nothing has.
The payment didn't go through because the take bet function didn't go through because the value has to be equal to the bet amount.
No, the constructor was a payable, right?
Yeah, the constructor was a payable, but then he just called the constructor. So what happens is that the constructor executes automatically when you pay someone, or well, no, when someone pays you. My bad. But then you could still call the constructor independently without payment. So what happened here was that he called the constructor, and he didn't transfer any money because he didn't he yeah he didn't transfer any money through a transfer or send function because like transfer hasn't been called yet. So then his balance is still 10.
I thought because take bet was also payable, but you didn't explicitly put send or transfer, then they still took ether from the person based on message value. So would it not be the same case for the constructor? Because I thought payable meant like you automatically.
Yeah, payable means you automatically execute it when transfer is called, send or transfer is called, but then transfer or send hasn't been called yet. So then so Matt's value is also the same because nothing has been transferred yet.
Oh, okay.
Yeah.
All right.
Answer your question.
Oh yeah, I think
Okay,
so.
cool. So then question 4, Tim calls review true. Yeah, so what is Matt ether balance? So remember that Matt took a bet as false. So let's go to reveal. Player 2 is Matt. And then now is obviously less than expiration, because if we scroll, where is expiration? Expiration is now plus 24 hours. And let's assume that 24 hours has not passed yet. So then we're good in that area. And then we want to require that should pass as well, because the ABI encode is equal. So then if player 2 choice is, so Matt chose false, choice is true, that's false. So then player 2 transfers his balance. And then, yeah, take bet, and the constructor execute, and he loses 1 ether because he has to transfer 1 ether to Tim. So they both had 10 originally. So Matt now has 9 ether and Tim has 11 ether. Yeah, does anyone have any questions? Anyone have any questions about the homework? You're all able to do it?
Okay, so when does this dot balance become 1? Because if you're transferring, it's dot transfer address this dot balance, right?
Yeah.
But when does that become 1? In take bet?
Wait, I thought that this dot balance was 2, and then like the contract had 2, and then that got transferred to player 1.
Yeah, that's what I thought. Yeah. That's
the contract the
If
contract
the
only
is
has
just
one.
player one dot transfer and then
Yeah.
the balance, and there's no reference to player two in that line. So player two should have already lost 1 ether.
Oh, yeah, so let's step through it again. So then bet amount is message.value. So bet amount will be 1. And then when you take bet, that just means that message.value is equal to bet amount. If balance was 2, then Tim and Matt had 9 before transfer was called, right? If balance was 2, then Tim and Matt would have 9. But then transfer hadn't been called, which means that their balance stays the same because it was 10 already. So then their balance would both be 10 because you haven't transferred anything after take bet. But when transfer was called, then it would be then one would be 9 and one would be 11. Because message.value stays as 1.
Wait, I think I didn't understand the chat comment. What do you mean if balance was 2, then Matt would have 9 before?
Okay, I can try to explain my line of reasoning. So for the question 1, I thought that if constructor is payable and they call constructor with a value of 1 ether, then they're paying the contract 1 ether. So at that point, I thought Tim was 9. So because you're paying the contract 1, and then if when Matt calls take bet with 1, then that one's also payable. So now you're paying the contract another 1. So now the contract should have 2 balance. And then once you finally call a transfer, it should transfer to player 1, which was Tim. So now 9 plus 2 is 11. That's what I thought.
Yeah, but balance is always 1 because bet amount always stays at 1 through the constructor. And then you're not actually transferring money to the contract in the
Oh,
constructor or take bet.
wait. Oh, okay.
Yeah, notice that you're not actually transferring money. So then it should stay as 1 because that amount is 1, and that would be the balance.
Okay, I think I need an explanation for the transfer function. When we put the argument to be addressed this dot balance, that means you what does that represent? The address of this dot balance.
This represents, so then this would be the contract. So then it gets the address of this contract, and then it transfers to, and then message.sender. So then like the sender transfers this balance to the contract. Yeah. Do you need to specify who you're transferring to? Well, what happens is that yeah, so then the sender is the one transferring to the contract. Um, Let me. Yeah, should I review transfer in last lecture? I think that would be pretty helpful. Yeah. So let's go to this lecture. Yeah. So then I'm going to review transfer. Development tools, Remix IDE. Yeah, so let's talk about, public payable. And what happens is that it sends Ether along with this creation because you modify the value over here. So where is transfer? Address payable, but then you could transfer and send. So then here is the transfer function. Where's the transfer function? Payable, yeah. Start presentation. So then that just transfers the amount. Where you see like address payable is X. So then that means the address X could pay you money. And then you transfer to yourself because you transfer 10 to the contract itself. And send is similar, but then send would stop if execution fails. So an address just holds a 20-byte value. An address payable, it could transfer and send you money. So then here is how it works. Yeah, so then back to the homework. What happens is that it's sending, the sender is transferring the balance of this contract to this contract. So then in reveal, this player transfers money to you. Yeah, my siblings playing piano. Okay, yeah, my bad. So what happens is that you're transferring money to this player, and that's how it works. So player 2.transfer. And yeah, that should be it.
So logically, if player 2 choice is equal to choice, that means player 2 should win. Then player 2 will receive money, right?
Yeah. Yeah. I think I think this function is missing the extra line where you take money from player 1. Oh wait. Oh, hold up. Mm, yeah, player 1 dot transfer is called. Well, yeah. So what happens is that the balance is 9 for both of them, and then you're transferring 2 to the to player to the winning player. Yeah. So that's how it works. Yeah. My bad. My bad. Yeah, because it looks like in take bet, you're taking a bet amount, and then when the message sends you, like they send a value of 1 each time, so then the balance becomes 2, and then in that case, you just um in that case you just transfer the money away, and then payable works in this scenario because these are the two functions that receive the message and they add the Ethereum to the balance of the contract. And in the case of cancel and reveal, what happens is that you're transferring money away, so you don't need payable. But you need payable if the contract is receiving money from the players. Yeah, I hope that answers your questions. Yeah, does anyone else have any questions? Yeah, cool. Yeah, so this week you guys have no homework. Hope to see you back at 6:10 Berkeley time. I'll be on time next time. Yeah. See you. Bye.